Right. This is your section on exponential growth and decay. First formula is for continuously compounded interest, so dealing with money. P is your initial amount, R is your rate, and the key word here is you're looking for it has to be compounded at a continuous rate. All right, example 1. Suppose you invest $11,500 at an interest rate of 3.3% per year, compounded continuously. Give the exponential function, P of t. So P of t equals the amount we started with, 11,500, e to the decimal form of the rate. Rate was 3.3%, so that is 0.33 t. T is our time in months. P of t is the amount, and that's dollars. All right, part B, how much do you have in the account after 3 years? So after 3 years, that is a unit of time. So that is telling us that t equals 3. So we're plugging in 3 for t. So we've got P of 3 is 11,500. E to the 0.033 times 3. So then we go to our calculator. Make sure you use your E button here. And we wind up with 11.5 E 12.9 or 12.696 point, and then it's 762. Read to make sure you round correctly. Nearest hundredth, so that would be, this is dollars, $12,696.76. All right, part B, how many years, so that means we're looking for T, does it take for the amount of money to double? So we're explicitly not given the amount, but we're given enough to find it. So double means double what we started. So that's going to be twice what we deposited, which is the 11,500, which is 23,000. All right, plugging in. 23,000 equals 11.5 e to the 0.033 t. So exponential equations, remember you need the base with the exponent completely by itself. So we're going to divide off the 11.5. Divide off the 11.5. It's going to give us 2 equals e to the 0.033 t. Once it's by itself, you take a log of both sides. I like a natural log, so I'm going to take the natural log of both sides. Remember, the natural log of e is the exponent, so this is the natural log of 2 equals 0.033 t. We divide off the rate. Divide off the rate. So we wind up with t equals the natural log of 2 over 0.033, which is just natural log of 2 over the rate. So from our calculator, that is 21.004. Go reread. Round to the nearest hundredth. So then remember, that's 2 decimal places. So 21.00 years. And that right there is actually a formula that we're fixing to go over. So instead of doing it this way, you actually have a short way you can do this now. All right, next formula is for exponential growth and exponential decay. So these are actually the same formulas with the exception of, look at the exponent. Growing has a positive exponent. Decaying has a negative exponent. And the relationship for K is the natural log of 2 divided by T, which is the amount of time it takes to double. Oh, I drew a square. It's not, there we go. And then down here, K is still the natural log of 2 over T, but that is the time it takes to cut itself in half. So half versus doubling time. So make sure you know which one you're looking at. All right, next. Under ideal conditions, a population of rabbits has an exponential growth rate of 11.7% per day. Suppose a particular area has an initial population of 100 rabbits. Write the exponential growth model R of t that can be used to find the population after t days. So R of t equals, we started with 100. E, it's growth, so positive. KT, where K is the growth rate, so 11.7, so 0.117 T. All right, T is our time, and it's in days. R of T is the amount, and it's in rabbits. I guess you could say population instead of amount, rabbits. All right, part B. What will the population be after 7 days? Days, their unit of time. So that's telling us T is 7. So R of 7, 100 E to the 0.117 times 7. And we type that in, use your E button, and we get 226.823. Read to make sure you answer correctly. So if we read answer to the nearest rabbit, we can have parts of rabbits. Oh, stop moving. There we go. So that would be 227 rabbits. Kind of made it fit. Rectangle, please. There we go. All right. Part C, find the doubling time t. So there's actually 2 ways we can do this part here. We can do it just like we did in the last example, but now that we know the formula, I would rather do this the quick way. So the doubling time t, or half-life, is the natural log of 2 divided by the growth rate, or if it was decay rate, k. So for us, t is the natural log of 2 divided by 0.117. So if we do ln of 2 divided by 0.117, we get 5.924. Go read. Answer to the nearest. I had a typo here that should say days. So we'll fix that real quick. I'll fix it on your copy. So answer to the nearest day. So that would be 5.9 is going to be 6 days. Right?